Hello everyone and welcome to the module on industrial water reuse. My name is Marjolein. I'm a postdoc at Ghent University working on the chair Industrial and Circular Water Technology with Evides, a Dutch company producing both high purity process water for industry and drinking water for the Netherlands. Water is paramount in most industrial processes, whether it's as a solvent, as a transporter of heat, to produce energy, or simply to use in products or to clean machinery. Depending on the region of the world, 5 to 70% of the total water use is attributed to industry, with agriculture taking a second place and a small fraction going directly to households. By combining these three water needs for our products and food, we can calculate their individual and our total water footprint. This footprint can be divided into a green, grey and blue water use, with the blue water being the water we withdraw from natural water sources. The grey water indicates the volume of water required to assimilate pollutants to meet specific water quality standards, while the green water represents the water that is naturally taken up by plants used in the process. The average worldwide blue water footprint of industrial products is 4 cubic meters per $1,000 of value added, while the grey water footprint is 39 cubic meters on average. Important efforts are being made by industry to decrease their water use and impact on the environment. Traditionally, most wastewater streams from different processes are mixed and treated in one central water treatment plant. However, this makes it difficult to recover water because all the solutes need to be removed, and it also hampers the recovery of any interesting solutes because they are mixed in with everything else. That is why efforts are now more and more focusing towards process intensification, where the water cycle of single processes or groups of similar processes is optimized. This makes it much easier to recover interesting resources, since any contaminants are process-specific and any interesting solutes are more concentrated. But it requires openness of industry towards their processes. Besides optimizing internal water cycles, climate change and increasing populations are forcing industry to switch from traditional water sources, such as groundwater and surface water, to alternative water sources, such as domestic or industrial wastewater and even seawater. Although this ensures water security, new water sources come with new contaminants to deal with. Traditional and existing treatment facilities are not always able to deal with these contaminants, and often their impact on the treatment and subsequent processes is unknown. For example, along with carrying solutes, the water can also carry microorganisms, which are happy to grow in the water and cause all kinds of trouble, such as growth of pathogens and clogging of equipment. Furthermore, contaminants in the water can cause corrosion of all kinds of materials, especially when exposed to high temperatures and pressures. In this module, we will dive into all kinds of roles that water plays in industry and what the impact of the water quality on the industrial processes can be. In this module, we will introduce you to water reuse in industry and to the many wondrous roles water plays there. After completing it, you will be able to list the various ways water is used in industry and how it impacts industrial processes, both negatively and positively. You will be able to propose appropriate testing routes for alternative water sources and to assess the results from lab and pilot scale testing regarding the use of these sources. As such, you will be able to assess which treatment option is the most interesting in practice, based on experimental results. We hope you enjoy this module. Happy learning!